Here's 4.5, part 3. Part 3. This is our last graph that we're going to graph is the function 1/3 sine of pi x minus 2. So we have a few changes from the parent function. So like I said before, I take the pieces out that are different from the parent function and then graph second. So what is the a value? What is the value of a in this equation? 1/3. So then what is our amplitude? 1/3. Absolute value of 1/3 is 1/3. So that means our graph is going to be a lot tighter along the y-axis. It's going to be shorter, not as tall of a sine wave. What's the b value? This is my b value. So it's pi. So this looks a little different than the last examples. If I find the period of 2 pi over b, and that means I substitute the pi in, 2 pi over pi, the pi's cancel, and we're left with 2. That still represents 2 radians. You just don't have it in form of a pi. So it's 2 radians. Is there any translations up or down? Yes. Where does that occur in the equation? -2. I have a d, so that tells me I'm going to go down. You agree? Okay. So we're going to go down 2 units. When I graph vertical or horizontal translations, I take care of those first on my graph. So all of our examples so far have been 0 translations up or down. So they started, in that middle of the road along the y-axis. What we do when we graph these is we graph an imaginary dotted line. So if I just kind of pick this up, and if this is my, x-axis and my y-axis, normally the middle will be right here. What we have to do is we have to shift down 2 units. So here would be -1, here would be -2. And we're going to draw an imaginary dotted line to help guide us with our 4 points. So there's our shift down 2 at y equals -2. Then from there, I construct my amplitude pieces. How big was my amplitude? 1/3. So pretty small. Here's a third, here's a third, here's a third. So it's going to be the top of that, is it cosine or sine? Sine function is going to be -1 and 2/3. And then I go another distance of 1/3 the other way. So if here is, let's say, -3, the bottom of that curve will occur at -2 and 1/3. So the graph will occur only in this piece. All right. And now we're going to graph it. Yep. So, looking back at my period was 2 pi. Or, I'm sorry, 2. So if I come back to this original axis, here's 0, I have to go 2 radians. So there would be 2 radians. Halfway would be 1 radian. Halfway would be 0.5 of a radian. And then 1.5 of a radian. If you want fractions, you can use fractions. But it cannot have pi in it. Then, was there reflections going on? Was there a negative a? No negative a. So we can go right to the middle. So instead of us starting at the x-axis, we're going to start at that red dotted line. And it's a sine function. So where are we going first? Up to the top, then to the middle, then to the bottom, and then to the middle. There is one revolution. If you were to continue it, you would add on another 2 radians, split up into 4 equal parts, and continue the pattern. Sound good? Do you want me to do that piece? Are we okay? All right. There is your assignment for today. The directions in the book are a little different than what we want you to do. In the 1 through 6, just do it as it says in the book. But the rest, we want you to go out and graph them. Graph paper does, I think, make it easier to graph these too. Because you're not having to make so many lines, and it's a little more accurate. So your choice if you want to use graph paper or not, if you have it, but I would recommend it. And then Monday, the next 4.5 day 2 will introduce the translations left and right and kind of some application type problems that you might see.